All right, so I'm going to review some of the questions that are on the unit review. A lot of these people asked, some of them people didn't. I'm trying to get to most of them. And so I'm going to start here with number 2. And it says solve the inequality x minus 5 over x plus 6 is less than or equal to 0. All right, so I'm going to start with the critical points. Now, the critical points are where it equals 0, which in our case is x equals 5. And then anywhere it's undefined, and that would be where x equals negative 6. We are going to put these two numbers on a number line. And then I'm going to see the intervals where it's negative and where it's positive. If I plugged in a -7, for example, I would have a negative number over a negative number, which would give me something that's positive. If I plugged in something between -6 and 5, I'll plug in 0. I would have a -5 over 6. So that would be negative. If I plugged in something bigger than 5, let's say 6, I would have a positive over a positive, and that would be positive. All right, now, we want to see where it's less than or equal to 0. So we want this interval here where it's negative. Now, the question says greater than or less than or equal to, so I can equal 5, because if I equal 5, then it will equal exactly 0. If I equaled -6, though, that would make the denominator 0, which would make it undefined. So that's going to be an open circle. So the solution is going to be from -6 to 5, including 5. All right, next question is 3. So this is similar, but one side does not equal to 0. All right, which means I need to make the other one side set equal to 0. So I'm going to subtract 3 from both sides. And make that greater than 0. Now I'm going to find a common denominator. The common denominator is x minus 20. So I have an x minus 19 over x minus 20 minus 3 times x minus 20 over x minus 20 is greater than 0. So I'm going to add like terms in the denominator. Let's go ahead and distribute that -3. So negative 3x plus 60 over x minus 20. So I wrote it all over the same common denominator. So what do I have? I have a x minus 3x, which is a -2x. And I have a 60 minus 19. So 41. X minus 20 over x minus 20 is greater than 0. All right, so let's go ahead and find our critical points. That's where the numerator equals 0. And if that is equal to 0, then I have a -2x equals a -41, x equals 41 over 2. All right, and then where the denominator equals 0 and it is 20. So I'm going to put those on a number line. And 41 over 2 is just a little bit bigger than 20. So we have 20 and I have 41 over 2. All right. Now, this is greater than, not greater than or equal to. So I can't equal either of those points, right? I can't equal the 20 because that would make it undefined. And I can't equal 41 over 2 because that's exactly 0. All right, so now I'm going to put something in each of these intervals. Let's plug in something less than 0 or less than 20. So I'm going to plug in 0. So I would get a 41 over -20, and that is a negative number. All right, now between 20 and 41 over 2. So that would be like 20.1. All right, so if I plugged in 20.1, I would get something positive in the denominator. And I would get what? Something negative 2 times 20. I would get something positive in the numerator. I'd also get something positive in the denominator. So that's going to give me something positive. And if I picked something bigger than 41 over 2, let's say 42, then I'm going to get something negative in the numerator and something positive in the denominator, which is going to give me something negative. So the interval that I want is greater than 0. So that's going to be between 20 and 41 over 2. All right. Next question is number 4. And this is just factor. So the first thing I'm going to do is I'm going to rewrite it as x squared plus 35 over x squared minus 7 to the 1/2 times x plus x squared minus 7 to the 1/2 times 5x. All right, so I think the first thing that I want to do is find a common denominator. And that common denominator is going to be x squared minus 7 to the 1/2. So the first term is going to stay the same because it has the common denominator. And then the second term, I'm going to multiply the top and the bottom by x squared minus 7 to the 1/2. And it already had an x squared minus 7 to the 1/2 and a 5x. So if I write it over the same common denominator, what I'm going to do here, the first term, I'm going to distribute that x so that I get an x cubed plus 35x. And now, if I have x squared minus 7 to the 1/2 times x squared minus 7 to the 1/2, that just gives me x squared minus 7. All right, so now I'm going to distribute that 5x, and I get a 5x. How did that 35 become a 55? Let's change that. All right, so I have a 5x times x squared, which gives me a 5x cubed, and then a 5x times a negative 7, negative 35x. Over x squared minus 7 to the 1/2. And my 35x, negative 35x cancels. I have an x cubed plus a 5x cubed, which is a 6x cubed, over x squared minus 7 to the 1/2. And that is it. All right, next question. This is question number 11. Find an equation of the line in the form ax plus by equals c, where a, b, and c are integers with no factor common to all three, and a is greater than or equal to 0. The line with y-intercept 8 and perpendicular to x plus 6y equals 13. All right, so if I have the line 6y equals, or x plus 6y equals 13, what I want to do is I want to find the slope, and then to find a perpendicular slope, you have opposite reciprocal. So I'm going to start by solving for y. So I have a 6y minus x plus 13, and now I'm going to divide by 6, and I have a negative x over 6 plus 13 over 6. All right, so the slope of this line is negative 1 over 6. So the slope of the line that I want, the slope of the perpendicular line, is going to be opposite reciprocal. So change the sign and then flip it, which gives me 6. All right, and they also told me that the y-intercept is 8. So my equation is going to be y equals mx plus b, where y is, or m is 6, and b is 8. Now, the way they wanted it was ax plus by So I need the y and the x to be on the same side. And I also need a to be greater than or equal to 0. So I need to leave that 6x on that side. I'm going to switch the 8 and the y so that I get a negative 8 equals 6x minus y. So 6x minus y equals negative 8 is the equation of our line in the particular form that they asked us to put it in. All right, next question. So to produce x units of a religious metal cost C of x equals 14x plus 85. The revenue is Rx equals 31x. Both cost and revenue are in dollars. The first question is the break even. So break even is when the revenue equals cost. So revenue equal to cost. My revenue is 31x. My cost function is 14x plus 85. So I need to find the value that makes it break even. So let's solve for x. 31 minus 14, 17x equals 85. And that gives me x equals 5. So 5 units will let me break even. Part B is find the profit from 250 units. Okay, so what I first need to do is I need to find the profit function. And the profit function is revenue minus cost. So P of x equals R of x minus C of x. My R of x is 31x, and my C of x is 14x plus 85. So 31x minus 14x we found was 17x, and we have to distribute the negative sign, so we get minus 85, and that's my profit function. We want to know the profit when we have 250 units. So when x equals 250, so P of 250 equals 17 times 250 minus 85. So 17 times 250 is 4,250 minus 85 gives me 4,165. All right, and then part C says find the number of units that must be produced for a profit of 170. So I want my profit to be 170. So 170 equal to my profit function and solve for x. So I have 170 plus 85 is 255 equals 17x divided by 17, and I get 15 units. All right, next question. This is question number 18. Joanne sells silk screen t-shirts at common community festivals and craft fairs. Her marginal cost to produce one t-shirt is $250. Her total cost to produce 50 t-shirts is $175. And she sells them for $8 each. Okay, so what I need is I need to have a cost function, because they are asking to find the linear cost function. So the cost function equals the fixed cost plus the variable cost. Now, they tell us that the variable cost is $250 because they tell us the marginal cost is $250, which is how much it costs for one additional. And since it's a linear function, it's going to consistently be $250. So it's going to be 250x. Now, I don't know the fixed cost, so we need to be able to come up with a cost function. I need to come up with a fixed cost. But they do tell me if I have 50 t-shirts and I sell them, she sells them for $8 each, I have $175. All right, so $175 equals F, my fixed cost, plus 250 times how many t-shirts? 50. All right, so 250 times 50 is 125. So 175 minus 125 is going to be 50. So my fixed cost is 50. So now I can write my cost function is 50 plus 2.5x. All right, the next question, part B, is how many t-shirts must she produce and sell in order to break even? All right, and remember that our break even is when our cost function equals our revenue function. All right, my cost function, we already found. My revenue function is going to be the price times the number of units sold. All right, so in our case, they tell us the price is 8 and the number of units sold is going to be our variable X. So what we need to do now is set our revenue function equal to our cost function. All right, so my cost function was 50 plus 2.5x, and my revenue function is 8x. So I have 8 minus 2.5, which gives me 5.5x. Whoops. So 50 divided by 5.5, whoops, equals 9.09. All right, but I want to know how many they must sell. So I have to round up to the 10, right? Because if I sold just 9, I wouldn't break even. So I need 10. So I need 10 shirts to break even. The next question is, how many t-shirts must she produce and sell to make a profit of 700? So again, we need our profit function, which is revenue minus cost. Our revenue is 8x. Our cost is 50 plus 2.5. 8x minus 2.5x is 5.5. And distribute that negative sign and we get 50. All right, so I want a profit of 700. So 700 equals 5.5x minus 50. Add 50 to both sides. So I have 750 divided by 5.5, which gives me 136.36. So that would not make 136 would not make a profit of at least 700. So I need 137 t-shirts. All right, next question. 25, give the domain of the function defined as follows. Now, when I have a square root function, I need everything under the square root to be greater than or equal to 0. But since that square root is in the denominator, it cannot equal 0. So I need 4x squared plus 7x minus 2 to be greater than 0. All right, I need to factor that left side so I can find my critical points. I'm going to use the AC method. So I need two numbers to multiply to give me -8 and add to give me 7. So that would be plus 8x minus x I'm going to factor the first two, and I'm going to factor out a 4x, and that is going to leave me with an x plus 2. And then I'm going to factor out a negative sign from the second two, and that gives me an x plus 2. Factor out an x plus 2, and I'm going to get a 4x minus 1. So my critical numbers are going to be x equals negative 2 and x equals 1/4. Put those on my number line. I have a negative 2 and a 1/4. Choose a number less than negative 2 in that interval. So let's say negative 3. That's going to give me something negative times a negative, which gives me something that is positive. All right, let's choose a number between negative 2 and 1/4. Let's say 0. That's going to give me a 2 times a negative 1, which gives me something negative. Let's choose something larger than 1/4. Let's say 1. That's going to give me something positive times something positive. So that's going to give me something positive. Now, we already said they cannot equal these numbers because they're in the denominator, and that would make it undefined. I need greater than, so that's where it's going to be positive. So my domain is going to be from negative infinity to negative 2, union 1/4 to infinity. All right, next question. So this is question number 33. A manager of a 50-unit apartment complex is trying to decide what rent to charge. Experience has shown that a rent of $700, all of the units will be full. Okay, so if the rent is $700, all the rooms will be full. On the average, one additional unit will be vacant for each $35 increase. Okay, so the first question, part A, let X represent the number of $35 increase. Find an expression for the rent of the apartment. So they say the rent is $700, and then for each one that is vacant, an extra $35. So that is going to give me 700 plus the 35x. Right, now part B says find an expression for the number of apartments rented. Well, there's 50, and then however many additional ones we subtract off, right? Because for each vacant one, it increases $35. So we have 50 minus X, right? 50 minus the number of units that are vacant. All right, so we want to find a revenue function. All right, and remember, revenue is going to be the number of units times the price. All right, so in our case, our number of units is 50 minus X, and the price is 700 plus 35X. If we FOIL, I'm going to have 50 times 700, which gives me what? 3,500. 50 times 35x is 175x. Negative x plus 700 gives me a negative 700x. And then a negative x times 35 is 35, negative 35x squared. All right. I think I lost a 0 here, right? Because it was 50 times 35, not 5 times 35. All right, so I'm going to add like terms and write it in descending order. So I have 35x squared, 1,750 minus 700 gives me 1,050x plus 35,000. All right, now the next question is what value of x leads to a maximum number of revenue, right? And what we know is this is an upside down parabola. One second, I have a friend whose dad is in the ICU with COVID. Okay, so I just had to get her text just in case. All right, so what I was saying is this is a parabola. It's an upside down parabola, right? Because the leading coefficient is negative. And I know that that maximum is going to happen at the vertex, right? That's where my maximum is going to happen. So I need to find the vertex, right? So you can do it by completing the square, or you can find it by negative b over 2a. All right, so in our case, negative b is going to be negative 1,050 over 2 times negative 35. So that is what, 1,050 over 70. And that gives me exactly 15. All right, so that is going to give me the maximum amount of revenue. All right, because I found the vertex of the revenue function. And then they're saying, what is the maximum revenue? Well, then I need to find the y value, right? So I'm just going to plug in 15 to my revenue function. Negative 35 times 15 squared plus 1,050 times 15 plus 35,000. Right, so I have 15 squared times negative 35, negative 7,875 plus 1,050 times 15 plus 35,000 is a 50,750, and that is going to give me 42,875. All right, next question. This is 38. Y equals x plus 3 over x minus 4. Find the horizontal and vertical asymptotes and any holes that may exist. All right, so there's a couple ways that we can find asymptotes, right? So the vertical asymptotes are when the denominator equals 0 and there's not the same factor in the numerator, right? If it were a hole, the limit would exist and it would be a removable discontinuity, all right? But there is not that factor in the numerator. So x equals 4 is going to be my vertical asymptote. All right, for my horizontal asymptote, it's leading coefficient over leading coefficient. So that would be if the degrees are the same, and that's what I have, the degrees are the same. So it would be 1 over 1, which equals 1. The other way is we could take the limit as x goes to infinity of x plus 3 over x minus 4. And what we always do is we divide by the highest degree in the denominator. So that would be x. And that would reduce to 1 plus 3 over x over 1 minus 4 over x. And we know if the top is constant and the x is going to infinity, then that term is going to 0. So I end up with 1 over 1, which equals 1. So y equals 1 is my horizontal asymptote, and x equals 4 is my vertical asymptote. Then they want us to choose the correct graph. All right, so first of all, I notice that y equals negative 1 is their horizontal asymptote, so that's wrong. This one, they have the vertical and horizontal asymptote wrong. This one, they have the vertical asymptote as x equals 0. So the only one it could be is this one right here. All right, next question. All right, the next question, I put 3 questions on here. So number 42 says solve this equation. So what I'm going to do, come here, Tiny. This question I can write with the same basis, right? because 9 squared is 81. So that's what I'm going to do. So I have a 9x plus 3 equals 9 to the 2 times 3x minus 3. If the bases are the same, I can set the exponents equal to each other. So I have an x plus 3 equals 2 times 3x minus 3. All right, let's go ahead and distribute that 2. So I get a 6x minus 6. And I'm going to subtract x from the right, and then I'm going to add 6, and I get a 9. Wait a minute, did I do that right? I get a 5x over 9. And then I get x equals 9/5. All right, write these each side of the equation as a power of 3. I wrote it as a power of 9, so I would accept that as well. And then the answer is 9/5. All right, next question. This is 47, and it's to solve for x, log base 4 of x plus 59 plus log base 4 of x minus 1. All right, now I have to combine the logs on the left side, and the way that I can combine, since they're being added, is to write it as multiplication. So x plus 59 times x minus 1 equals 4. All right, now, since I don't have a log on both sides, I have to rewrite it in exponential form. And let's remember that if I have log base b of x equals y, then b to the y equals x. So I want to write it in this form here. All right, so I have 4 to the 4 equals x plus 59 times x minus 1. All right, I am going to run out of room. Let's see, let's put this question up here for the time being. All right, so 4 to the 4th is what? 256. And then I need to FOIL this side, so I have an x squared plus 58x minus 59. So let's add 256 to the other, or subtract 256. So I have a 59. I get 315. So I have an x squared minus 315x, whoops, plus 58x minus 315. All right, so I can come up with two numbers that multiply to be 315 and add to be 58. So what is 315 is 5 times 63, and the difference of that is 58. So those are my numbers. So I need an x times x plus 63 times an x minus 5. Now, remember, when I have solved my logarithmic equations, I have to check to make sure that the answer works, right? Because if I plug in a number and I have to take a log of a negative number, then that is an extraneous solution. That solution does not work. So if you notice, if I plug in negative 63 to here, I would take a log of a negative number, and I would take a log of a negative number here. So that is clearly not the answer. So now what I'm going to do is I'm just going to check to see that x equals 5 works. All right, so I have a log base 4 of 5 plus 59 plus log base 4 of 5 minus 1 equals 4. So 59 plus 5 is 64. Plus log base 4 of 4 equals 4. So I need to know what number do I raise 4 to that will give me 64. And I believe that's 3. So 4 cubed is 64. Good. And then I know log base 4 of 4 is 1. So 4 equals 4. And that's true. So my answer is x equals 5. That is my only solution. All right. Then let's take a look at number 51. I'm going to erase all of this. Excuse me. All right, so I have a 2 to the x plus 2 equals 9 to the x. Now, clearly I cannot write 2 and 9 as the same base. So what I'm going to have to do is, since the variable is in the exponent, I'm going to have to take the natural log of both sides. So the natural log of 2 to the x plus 2, you can technically take the log of both sides. I just naturally always choose natural log. All right, and what that does means I can bring the exponent out in front. So x plus 2 times natural log of 2 equals x times natural log of 9. Excuse me. All right, so on the left side, I'm going to distribute my natural log of 2. So I have x natural log of 2 plus 2 natural log of 2 equals x natural log of 9. Now, what I want to do, I want to solve for x. So everything with an x, I'm going to put on the left side. Everything without an x, I'm going to put on the right side. So I have an x. Oh, shoot. X natural log of 2 minus x natural log of 9 equals negative 2 natural log of 2. So now what I'm going to do is I'm going to factor out the x on the left side. So I have an x natural log of 2 minus natural log of 9 equals negative 2 natural log of 2. All right, and then divide both sides by natural log of 2 minus natural log of 9. All right, so this is my solution. They wanted a decimal value. So you need to make sure that you round it to the correct decimal value that they ask you to. Next question, number 52. When an antibiotic is introduced into a culture of 80,000 bacteria, the number of bacteria decreases exponentially. After 5 hours, there are only 30,000 bacteria. Write an exponential equation to express the growth function y in terms of time t in hours. So it should look like this, right? Where P naught is the original amount, K is your growth or decay in our case, and T is time. They give us P naught is 80,000. They tell us when T is 5, then P of T, the amount, is 30,000. So what I can do with this information is solve for K, and that will give me my expression. So 30,000 equals 80,000. E to the KT, K times 5. I'm going to divide by 80,000. So 1, 2, 3, 4 zeros, 1, 2, 3, 4. So I get an 3/8 equals e to the 5k. So we are solving for k. I'm going to take the natural log of both sides. All right, and the right side, since I have the natural log of e, is going to equal just 5k. So k is equal to natural log of 3/8 over 5. Right, so I'm getting a negative 0.196165851, and they said round to 3 decimal places. So that's going to give me a negative 0.916. All right, so the function that I want is P of t equals P naught, which is 80,000, e to the k, which is negative 0.196 t. All right. B says in how many hours will half the number of bacteria remain? All right, so we want half of 80,000. So 40,000 equals 80,000 e to the negative 1.96 t. When I divide 40,000 by 80,000, I get 1/2. And we are solving for t. So I need to bring the exponent down. So I'm going to take the natural log of both sides. And since I have the natural log of e, I just get what's in the exponent, which is a negative 1.96 t. So t is equal to natural log of 1/2 over negative 1.96. And it says round to 1 decimal place. So I have natural log of 1/2 divided by negative 1.96. Let me try that one more time. Oh, I moved my decimal point. That would be the problem. Why did I do that? So all of these should be negative 0.196 t. I apologize. Okay, so here we go. We have the natural log of 1/2 divided by negative 0.196, which gives me a 3.536 round to 1 decimal place, and that's going to give me 3.5. All right, so 3.5 hours. Next question is use properties of limits to find the indicated limit. So I have the limit as x goes to 4 of x squared plus 3x minus 28 over x squared minus 16. Now, I can't do a direct substitution because if I plug in 4, I'm going to get something that's undefined. So what I'm going to do is I'm going to factor the numerator, factor the denominator, and see if I have anything that cancels. So the top is going to cancel as x plus 7 times x minus 4. The denominator is going to factor as x minus 4 times x plus 4. Right, my x minus 4's cancel, and I get the limit as x goes to 4 of x plus 7 over x plus 4. Now I can directly substitute in, so I have a 4 plus 7 over a 4 plus 4, which gives me 11 over 8. All right, question 67. Another limit question. Again, I can't directly plug in because that would give me something that is undefined. So what I'm going to do is I'm going to multiply I'm going to rationalize the numerator, which means I'm going to multiply the top and the bottom by the conjugate of the numerator. So the square root of x plus 7 over the square root of x plus 7. The key to this is to make sure you FOIL the top, but don't FOIL the bottom. All right, square root of x times square root of x gives me x. Outer is going to be 7 square root of x. Inner, negative 7 square root of x. And last, negative 49. Over x minus 49 over or times square root of x plus 7. All right, add like terms. And I get an x minus 49 over x minus 49 times the square root of x plus 7. So now I can cancel my x minus 49. And what I'm left with is 1 over the square root of x plus 7. All right, and now I can plug in. So I have 1 over the square root of 49 plus 7. Well, the square root of 49 is 7, so I get a 1 over 7 plus 7, which is 1 over 14. And that's my limit. All right, next question is number 74. Let g of x equal x plus 5 over x squared minus 2x minus 35. Determine all the values for which x is discontinuous, and for each of these values of x, define g in some manner as to remove discontinuities. Okay, so first of all, what I'm going to do is I'm going to factor. And I get a x minus 7, the denominator, and x plus 5. All right, so what I know is my discontinuities are at x equals 7 and negative 5. All right, I have discontinuities of both of these places. Now, I can cancel this one and get an x minus 7. And because of that, I know that there's going to be a hole at negative 5. And I can still find the limit though. So if I want to find the limit as x goes to negative 5 of 1 over x minus 7, then I can just plug in minus 7, which equals negative 1 over 12. All right, so I found the limit, but it's still discontinuous. That means it's a removable discontinuity. The limit exists, but it's not defined. All right, now, the other one at x equals 7 is non-removable. So anytime you have a non-removable discontinuity, there is no way that you can, how did they write it? Remove the discontinuities, hence the name non-removable. But if I want to remove the discontinuity, I would define it at negative 12. All right, so I have two discontinuities, one at negative 5 and at 7. And the lesser discontinuity can be removed by defining g to be negative 112. All right, question number 76. Find the average rate of change of the function over the given interval. All right, so my average rate of change formula is f of b minus f of a over b minus a. In our case, that is f of 12 minus f of 0 over 12 minus 0. So if I plug in 12, what do I get? 12 times 4 is 48 plus 1. So I get a square root of 49 minus f of 0, which is going to be the square root of 1, over 12 minus 0. So the square root of 49 is 7 minus 1 over 12, which gives me 6 over 12, which is 1/2. All right, that's my average rate of change. All right, I thought I had an instantaneous rate of change. All right, let me just remind you no, I want to make sure that I get at least one instantaneous rate of change in here. So let me go to my math lab and find it. So I apologize. Now, there were a couple on here that were difficult to find the limit. I will not put one of those on there where the limit is really hard to find. I will stick to ones that are easy to compute, or at least you know how to compute. So I think they're near the end. So let's look at maybe 78. Here we go. So find the instantaneous rate of change. For the function f of x equals x squared plus 3x at x equals 2. All right, so what I'm going to do is you can find it by the limit as h goes to 0. You can go ahead and plug in 2 if you want to. I usually choose not to. So f of x plus h minus f of x over h. So I will plug in 2 at the end for x. So f of x plus h is going to be x plus h squared plus 3 times x plus h. Let me use this room over here. Right? Minus f of x. So our f of x is x squared plus 3x all over h. All right. So let's go ahead and FOIL x plus h squared. And that gives me an x squared plus 2xh plus h squared. Distribute the 3, so plus 3x plus 3h. Distribute the negative sign, minus x squared minus 3x. All right, Trig. And now let's go ahead and get rid of like terms. So x squared minus x squared, 3x minus 3x equals what I have left over in the numerator is a 2xh plus h squared plus 3h all over h. I'm going to factor out an h from the numerator, and I get a 2x plus h plus 3 all over h. And when I plug in h equals 0, I get a 2x plus 3. All right, I want the instantaneous velocity at 2. So I have a 2 times 2 plus 3, which equals 7. All right, that is the last question. Best of luck to everyone. Again, I'm going to have office hours tomorrow during period 5 at 11:45. All right.